All right, good. Excuse me. Good morning, and welcome to our first class of the semester. I am your digitally bound spirit host, professor. It was my sincere hope that we would be meeting in person as advertised, but hopefully this is just a temporary postponement. And hopefully we'll be back in person within 3 class periods. But we'll see. We'll have more on that in a little bit. So first off, allow me to say hello and welcome. My name is Josh, which you can totally call me if you don't feel comfortable calling me that. You can also call me by my last name, which is Tolo Pilo. It's a mouthful. Either way, I'm down. I can roll either way. Today we are going to today's intro first class of the semester. I'm going to hey Shannon. Oh, and I don't take attendance, so you don't have to worry about posting a thing in the feed, because that is not what I'm all about. So anyways, I'm gonna go through the syllabus, talk about some course policies, then we'll dive into our first lecture. Actually, get to talk about some chemistry. So this is an introductory chemistry course. It introduces fundamental principles of chemistry, including matter, physical states, chemical transformations, chemical equations, stoichiometry, etc. The first real important piece of information that I want to hit on are the course prereqs. There are specific prerequisites in the syllabus. You can look at them. I believe it's Math 100 is the FLC course or equivalent. Excuse me, at another college, or at a high school algebra is the equivalent. But the take home is that the prerequisite is algebra. All right, and here's what I want to stress coming in. If you are out there and you're listening and you are, when I say the word algebra, if that strikes a little fear in your heart, or you're like, oh, that's not my best thing, it's not my strong suit, I want to emphasize that if you are at all rusty or intimidated by algebra, then if you want to succeed in this course, you need to start reviewing and reacquaint yourself with the mathematics of algebra, because knowing how to solve algebraic problems, graphing, solving for x using exponents, radicals, etc., is fundamental to your success in the course. And because it's a prerequisite, it's the assumption that you're already adept in these techniques. So I'm not going to spend any lecture time going over algebra because it's a prerequisite. It's assumed that you know it coming in. So if you're rusty, if it's not your strong suit, or if maybe it's been a while, maybe it's been a few years, it's on you to get yourself the review you need, get yourself the practice you need, and bring yourself up to speed. And you'll want to do this as soon as possible, because your first exam is based 100% on algebra, and it is this week. So hang on. There we go. So the our first exam is based 100% on the prereqs. Amber, that is a great question. Give me 1 second. Let me throw some details up here, and then I'll give some topics. If you're like, okay, what do I need to review? What do I need to go after? I'll hit that in just 1 second. Let me just drop the details about the prerequisite exam. So because we are meeting digitally at this moment in time, all of our exams will be, or assuming we get back into the classroom, all of our exams will be written on paper. You know, you'll take it during the lecture period and etc. But because we're not, the prerequisite exam is on Canvas. It's a Canvas quiz. It will go live after lecture. So I believe I set it to go live when our lecture is done, and it is due. Let's see. I have this down. It is due on the 25th at 11:59. Oops. PM. All right, which the 25th, if I'm not mistaken, is Tuesday. So the night before. This is essentially 11:59 is a minute till midnight. But I can't set it for 12 because then technically it would be due on the 26th because 12 a.m. is the next day. And Amber, I will answer your question in just a second. I'll kind of flesh out some concepts. But it again, you can take it as soon as the end of lecture. That being said, so there's a couple things I want to. Oops, I'm so sorry. You never have to worry about your whiteboard changing shape on you when you're meeting in person. So a couple things that I want to point out. The first is you could take it as early as end of lecture. We could finish lecture. You could go on, take it, because it's Canvas. It'll be graded automatically. I've been so, and this is something we'll talk about in a little bit. But so I'm your lecture instructor. I am in charge of the lecture exams, and posting your final grades. However, you have a different instructor for your lab periods. It's the same one whether you're the morning or the afternoon lab. And he and I have been talking over email. I haven't actually met him in person. This is first semester teaching here, and as you know, we're digital at this moment in time. but he and I have been talking. I've given him a list of topics that will be on the test, and sorry. Julia, yes, there will totally be a time limit for this sucker. I can't remember what it is off the top of my head, but all of that information is on Canvas. So we'll check with that in a little bit. Like I said, you could take this at 10:20. However, been talking to the lab instructor. I've given him a list of um, topics that are going to be on the exam, and I believe he is planning on um, holding an algebra review um, in lab. This week. So, if you feel ready, you can totally dive in and take it. That being said, I believe the what's on slate for the lab period this week is you got to knock out your safety quiz, safety waiver, which you can do that at any time. It's available on Canvas right now. You could also wait to do it during the lab period. But I believe he's going to be leading some algebra review, working some problems. If you want to wait to see that and benefit from that time, so that's one thing that you may want to delay diving in. Second thing, yes. So, and actually, Julia, let me grab the time real quick off Canvas. Sorry, it'll just take me a second to log in here. All right. Oops. Knocked my stylus into my microphone. So let's see. Okay, so let's talk a little bit about just the general structure of the exam. So there are going to be 18 questions. And you will have 36 minutes to complete them. So if my head math is right, that comes down to about 2 minutes a question. These aren't going to be long or involved, but you will want to keep your eye on the clock. If you find that a problem is taking you longer than 2 minutes, you may want to skip it, come back, because again, you've got 2 minutes per problem. Matthew, that is a great question. Let me finish talking about the prereq exam, and I will answer it. So, all right. So let's talk about topics that are going to be on the exam. Okay. So as I said before, I'm just gonna move these over. So if you're wondering, okay, what should I review to get ready for this exam? These are the topics that will be covered. You will be asked to factor polynomials. you will need to do a series of solve for x problems, including that will test your skills on using radicals and integer exponents. Let's see. Multiplication, division, addition, subtraction, all the usual suspects. You will be asked to not only, there'll be problems that are just factoring polynomials, but you will also have to solve polynomials. And you'll have to solve systems of linear equations. All right, so those are the things that you can expect: solving for x, factoring polynomials, solving polynomials, solving systems of linear equations. These will be presented in a variety of formats. They're all going to be multiple choice or numerical answer. So you'll be solving for a number or selecting the correct answer. One thing that I want to point out is these exams, or this exam, employs problem banks. And so each student will receive a unique exam because, for example, for the factoring polynomials problem, the specific one that you get is drawn out of a bank of much larger problems that I've spent the past 2 years building up. And there is a statistical probability of two students drawing the same exam. And I did crunch the numbers this morning based on the number of students we have enrolled currently in the class. The chances of two students getting the same set of problems out of an exam is, 1.00, no, sorry, not 1 point, it's 0.000136 are the chances of two students drawing the same exam. So each student will be taking a unique test, statistically speaking. I'm pretty certain of this. But they'll have the same types of problems. So you'll ask to do the same number. So like, for example, you'll have the same number of factor this polynomial problem on your test. You'll just have a different one than the person who, I was about to say sitting next to you. I think we're all sitting alone in our rooms at this moment in time. But anyways, I just wanted to give you that insight into the format. Another thing I actually want to touch on before leaving, I'm going to pop back here, is I want to point out something about the time. So you have 36 minutes to take this test, which means you need to start 36 minutes before. All right, 36 minutes before the test closes. There's always one student who thinks they can game the system and um, thinks, oh, I'm gonna start this thing at 11:58. If you start at 11:58 p.m., then you get 1 minute to take the test. So don't be that dude. You don't want to be that dude. So just make sure you give yourself enough time. I recommend taking it early. I don't recommend taking it close to midnight at all, so your mind can be fresh and alert. But but just know that you need to give yourself at least 36 minutes of time. Otherwise, it's gonna cut you off, bump you out, and you're stuck with the score. You won't be able to retake the exam. So, okay, all right. So that was a lot about the prereq exam. Okay, Matthew, you've got a question about how the lab period is going to work since we're online. So fortunately, so I don't know exactly what platform the lab instructor is planning on hosting. My guess would be Zoom. Most instructors are using Zoom. I like YouTube because it's more user friendly and they store, they archive. YouTube will archive, all the videos without giving you like a storage cap or whatever. Zoom does that. Like you have to clear out your bank at the end of every semester. But we get all of our videos in perpetuity, so you never have to worry about them going away. You can always use them as a reference, which is why I prefer it. That being said, I don't know if the lab instructor is planning on using YouTube or Zoom. My guess would probably be Zoom. So it'll be held on Zoom. And fortunately, I believe our first wet experiment where we're going to be like actually doing an experiment, I believe that happens the third week of class, which is when we should be back in person. So the first couple weeks, and again, check out the, so I do not control the lab period. So ask your lab instructor for his syllabus, which will have a lab schedule in it, which will tell you when you're doing what each week. If he hasn't provided you a lab syllabus yet, or posted it to the lab Canvas site, send him an email, ask him to do so. And that'll have the lab schedule, which will tell you what we're doing each week. And again, I believe our first actual experiment is the third week of the semester. What usually happens with Chem 305 is it's a couple weeks of like review and kind of lab lectures, and then we sit down to actually do the experiments. So, Matthew, to answer your question, how's the lab going to work this semester? Assuming we're back to in-person instruction by week 3, which is what the Chancellor's office is saying right now, it should work totally normally, just with kind of digital streams for the first couple weeks, which are usually reviews anyway. If Los Rios changes things in the future, we'll have to roll with those changes, and we'll have more information once we know. But because we haven't been told go digital all semester, we're not planning to do that. If we are, then we'll have to restructure things, and we'll let you know how the department is deciding to execute. I realize it's a little bit unnerving not knowing. I totally feel the same. I am anxious to get back in the classroom. I think we're all a little desk weary, computer weary. I know I am. So anyways, that's all I have right now. For more specifics about your lab period, I would say look at your lab Canvas, look at your lab syllabus. If your instructor hasn't provided you with a lab syllabus yet, email him and ask him for that, because I'm sure he's been working on it based on the conversations I've had with him. Okay, so let's see. So Wow, we are still at the beginning of the syllabus. Um, it's the prereq exam absorbed a lot of time. The rest should move faster. There's information in the syllabus. If you haven't um, downloaded it yet, grab that PDF off of Canvas. You'll find it. So our syllabus. You can download from Canvas. There's links everywhere to this thing, but I would direct you to the course resources module. It has information on required materials, such as the textbook that we are teaching out of. You want, reliable internet access. You need access to Canvas. I will be, for as many digital streams as we're doing them over YouTube. So if you have a device that can access YouTube, that'll give you access to these. And a scientific calculator you'll need for the exams, because when we resume in person, you won't be able to use a phone. But another reason why you want to go download the syllabus is there is a quiz there, the syllabus quiz. It's found at the end of the syllabus. This thing is not hard. There's some simple questions. It even directs you to the section of the syllabus where the answer to those questions are located. The syllabus quiz is due. So you got to fill this out, submit it as a PDF to Canvas. Let's see, it is due very soon, in a couple days. It is due on Friday. Again, 11:59. Something you should know. If you do not submit a syllabus quiz, or if you're late, all right, so or if you submit it late, you will be dropped from the course. We have a wait list to get in. And normally, we'll take attendance like the first few days to see in lab, like the first week, to see, okay, who missed, drop the no-shows, add the waitlisted people who are present. But it's digital, so this is kind of the way of digitally seeing who's responsive. So if you do not submit the quiz, or you are late, if you submit your quiz it's due at 11:59, if you submit it at 12 a.m., or if you click submit at 11:59, but it doesn't register in Canvas till 12, you get dropped. All right, so get in there, download the syllabus quiz, fill it out, submit a PDF, and you're in. You're good. All right. So anyways, get on that if you want to remain in the course. All right. A little bit about format. So lecture is going to be in person. That being said, we're not in person right now. Again, the chancellor, FLC chancellor suspended classes for the first 2 weeks due to the surge in Omicron, based on the memo that the chancellor's office sent out, and based on the stuff that I've been reading. It seems like the Omicron thing is it's spiking now, but it should flatten out. So the plan is to return starting the third week of class, that week of January the 31st. I believe is supposed to be our first morning back. That's the plan. Plans can change. It's totally out of my control. It's whatever the chancellor's office says is what we all have to do. So again, knock on wood, we'll all be back. We'll be back for the first time in the classroom starting week 3. But if it not, we just got to roll with it. And you can count on me. I will be keeping you up to date and telling you what the plan is. That's what the plan is now. If it changes, I'll tell you what it changes to. And we all just kind of got to roll with it together. We're in this storm together. Okay, let's see here. Okay, one thing that I want to let you know. So lecture is in person for now and not yet. That being said, I have recorded from the summer session all of my lectures. All right, they're available here on this channel. There is a channel playlist titled Chem 305 lecture. And these are available to you to use as a study tool. The content of the lecture is going to be pretty much the same. The textbook doesn't change, the material I have to cover doesn't change. And so you can use these, again, as a study tool. You can listen ahead, for example, and because I have the lecture schedule, tentative lecture schedule in the syllabus, you can kind of keep pace. If you want to, you can listen to the lecture ahead of time to kind of like familiarize yourself with what we're going to be going on. And then when you come to class and we actually interact in person, again, hopefully, that'll be another repetition of the material. So you could use it that way. You can, if you are sick with COVID-19, for example, I strongly encourage you to, stay home and quarantine. If you do that and we're meeting in person, well, if we're meeting in person, yeah, stay home, right? But if you're worried about missing class, well, I've got this entire semester's worth of lectures banked. So you can still hear me lecture, you can still interact with the material. It might even be slightly better because you can pause me, you can rewind me, you can, when I get to a problem, you can pause me, work the problem yourself, unpause, see how it goes. You may actually like it more, a possible rewindable version of me, which the live one doesn't quite operate that way. So this is a resource that's available for you. It's on the site. You can make that. You can make use of it. You can also use it to stay on pace if you are having to stay home and quarantine. The one thing to note, because this was recorded in a different semester, again, it was recorded during the summer session of 2020. The specific details or like the due dates for the class, the assignments for the class will be different. So for example, when I taught this class, lab was digital. And so there may be students asking questions about that going on. None of that stuff, dated stuff is relevant, but the content is all very relevant to you. Okay, so we got some questions up in here. Some assignments we should be expecting weekly. Okay, so Julia, the weekly assignments are going to be coming at you through lab. And we'll get to the point set up later, but for the lecture assignments, I just basically just give, Julia, I will be getting, sorry, I'm tripping all over myself this morning. I'll be getting to that in a little bit when we talk about point structure, the assignments you should be expecting weekly. Shannon, great question. Do you have to watch lecture at a scheduled time? Shannon, you do not. So I don't take attendance live. So for example, for the next couple weeks. I will be streaming during our class time. If you want to be present and ask questions, you'll need to be live from 8:15 to 10:20. But I will. Sorry. But the videos will be available. You can totally watch them later. They'll just be up on the channel. So you can watch them later. You don't have to wake up. Again, the reason why I'm doing it live during the class period is because starting week 3, we should be back to the classroom. So I'm getting myself used to waking up earlier and being active and functional by 8:15. So that's why I'm doing it. But you don't have to be on here live while I'm streaming, while I'm lecturing. Okay. So we talked a little bit about this lecture bank. And you can use it to stay on pace if you're having to quarantine during COVID. If you have to miss an exam, if you're having to miss an exam because you're quarantining for COVID. So this is the policy in the syllabus. The score of one missed exam will be substituted by the average score of all other exams. In the class. Including the final. All right, so here's the policy. If you have to miss an exam because you're quarantining for COVID, the score of one missed exam this semester will be substituted by the average of all the other tests you take. So the prereq exam, all the other lecture exams, and the final, I will average your score and use that average to count for your score of your missed exam. Something you should know, you don't have to provide me with a positive COVID test or a doctor's note or anything like that. This is just the policy if you miss an exam. It's here to be that magic bullet that saves you for the one time where you're going to get COVID this semester and have to quarantine. If you miss an exam for another reason and then later get COVID, this policy only does it once. So if you miss a second exam, you get a score of 0 on that second exam, and that 0 will be a part of the calculated average that'll substitute in for your first exam. So with this course, you're really, I was gonna say you're allowed to miss one exam. You can miss as many as you want, it'll tank your grade. You can miss one exam and not have it destroy your grade, but you only get one of these. Okay, so my encouragement to you would be, don't use this frivolously, save it, because you never know when you're going to get sick and have to quarantine. And if you spend it frivolously, you can shoot yourself in the foot. But you're an adult, you're allowed to do that. I'm not here to stop you from making bad decisions. You're all adults. But being an adult means you have to live with the consequences. So don't use this frivolously. I'm begging you because I want what's best for you. Okay. Okay, can we use notes on the exams? Okay, great question. For the for the in-person exams, the ones that you take in class, closed book, closed note, closed internet, It's you just have to take it with your calculator that cannot access the internet, pencil and paper for the in class exams. For the prereq exam, which you're taking at home, you can use anything you want. Open notes, open internet, open whatever. That being said, the prereq exam is 36 minutes. You got 2 minutes per problem. So if you're having to Google stuff, you're probably losing time and you won't be able to finish the test. So be careful there. But yeah, you can have notes open. You can have, whatever study tools you want. If you're taking it at home, anything's fair game. If you're taking it in class, it's pencil, paper, calculator, but no notes. Great question, Ahmad. Okay, let's talk about class behavior. Sorry, my dyslexia is ever-present battle. Class behavior. This semester, class behavior boils down to two things. Be kind. Wear a mask. So first one, be kind. Please be considerate of those around you in the class. If you, and again, this is more relevant to when we're meeting in person. Hopefully we will be. But if you engage in disruptive behavior, like talking to another human, whatever, you'll be asked to leave the classroom. Here's the thing. I'm totally not against like socializing or whatever. And if you want to talk to your neighbor, you totally can, just not in the classroom. Yeah. So, just don't do it when we're there, because other people are there and trying to learn, trying to listen to lecture. You can totally have a conversation where people aren't trying to listen to lecture. So just be kind, be considerate. When we're online, it's easier to be mean to people online. Just, temper your words, your text, your messages with kindness. And we'll all get along and have a good time. The second policy, wear a mask, obviously does not apply to when we're streaming, but when we're back in person. So you have to wear a mask covering your nose while in class, in person. If you're not wearing a mask or wearing one inappropriately, you'll not be able to remain in lecture. So here's the deal. Like, this is not my policy. This is campus-wide, college-wide, district-wide. It's not my policy. I didn't make it, but I do have to enforce it. If you forget your mask, I can't let you be in lecture. So again, you got to do one of two things. One, find someone or a mask somewhere on campus. Keep a few extra in your car. We all should be relatively used to doing this by now, living in Sacramento County. But again, worst case scenario, you don't have one. You can't find one on campus. You don't have any in your car. You've got the bank of lectures. So I can't let you be in the classroom if you don't have a mask. But even if you have to miss that day in lecture, you can go to YouTube and watch it. So is a way for you to still interact with the material. But I can't let you be in the room if you're not wearing a mask or wearing one inappropriately. So you can't, let your nose hang free. Okay. So communication. So if you want to get a response directly from me, let's go. The two ways to get a guaranteed response. Oops. Oops. What's going on? Oh, hang on. Sorry, something got jacked. There we go. So the two ways to communicate with me is email or Canvas. If you send me a message on email or Canvas, you are guaranteed a response. Usually I'll be able to get back within 24 to 48 hours. Again, it depends. I've got multiple classes. It should be a busy semester. So if you email me around exam time, there's a bunch of other people doing it too. My ability to get back to you is dependent upon the volume of email within all of my inboxes. And I have multiple at different schools. So, but you can expect usually within 24 to 48 hours. I will be adding, it's not live yet, but you'll be seeing I'm adding a course Discord. This is to be, to help us learn, connect, talk to each other. But I don't check Discord religiously, and I if you send me a DM, there's a good chance that I'm gonna miss it because I manage several servers on there for several different courses at several different colleges. So the guaranteed way to get a response from me for something that's important is over email or Canvas DM. Okay, so let's talk about grades. So there are two components of your grade. There are lecture assignments and there are lab assignments. Your lab instructor will be providing you with more information on what specifically is due, but typically there's an experiment. You do the experiment, collect the data, and then there's questions and calculations you have to do for each one. And he'll be providing with his point structure, how he grades it, all that stuff. What you need to know is both of these, both the lecture and the lab portion of the class, even though they're taught by different humans, they both contribute to your overall grade in Chem 305, and it's weighted. So 70% of your grade is determined by your performance in lecture, 30% of your grade is determined by your performance in lab. So that's the overall thing. However you score in lab, it's worth 30% of your grade. However you score in lecture, it's worth 70. Now let's talk about lecture assignments. So you have, there is the prereq exam. There are 3 more exams, lecture exams, I'll call them, which are based on the material that we cover in lecture. There's the final. And then you have homework. I'm going to call this Canvas homework. And the syllabus quiz. The points breakdown is the syllabus quiz is worth 10 points. Canvas homework. Sorry, there we go. There are 8 of these. The Canvas homeworks are worth 15 points each. The final is 120 points. And then exams are 100 points each, including the prereq exam. It's weighted the same as the other lecture exams. All right. So these are the assignments in the class. The syllabus quiz is 10 points, and it's basically if you do it, you get all 10. So it's worth about what one of the homework assignments is, and it's basically free. I like that because I like everybody to start the semester with just this boost. There are 8 Canvas homeworks, which means you can expect them. So Julia, this gets to your question, what should you expect for weekly assignments? You will have weekly stuff to do in lab, but again, you'll get that information from your lab instructor. As far as lecture goes, there isn't really a weekly assignment. The closest thing that you'll come to it are the Canvas homeworks, and the due dates for these are in Canvas, but it's also, I believe, yeah, the due dates for those are all up in Canvas. You can see when each one is due if you look under assignments. Let me make a note of that. So these are what points are for. But now, Julia, tying back into your weekly assignment. So this is a college course, and I don't know. For some of you, it may be your first science class in college. Others, you may have taken other courses, but it's definitely not high school, and so I don't load a ton of assignments because my assumption is that you are working at this material, that you're self-motivated, that you're studying. And something you should also know about the Canvas homeworks, these are not meant to fully prepare you for the difficulty level of the exam. The Canvas homeworks are like the kind of easy introductory beginning problems. I wanted to have some reward you with some points, but it's the start of studying. If you only do these Canvas homeworks, you will not be ready to take the exam, because the exams are much harder. To fully prepare for the exams, you should do practice problems. From the textbook. I have assigned these, but they're not graded. You can find them on Canvas under course resources. On our Canvas page, there's a PDF of practice problems that I've assigned out of the textbook. You're going to want to be doing these daily, as often as you can, as many as you can. So I would, as you structure your study time, I would start with the Canvas homeworks, right? Because they're worth points. You want to get those points, but don't end with those. That can't be the end of your study, or you're not going to be ready to take the exam. So the kind of strategy and design behind the Canvas homework is I wanted to give everybody some points. And you'll see there's 8 Canvas homeworks, each worth 15 points. That's a total of 120 points over the course of the semester. So for doing this kind of intro, beginning to study, 120 points, you'll notice, is what your final exam is worth. So if you do those, that's 120 points. That's the same amount as the final. I want to kind of reward you and give everybody kind of that entry base level. But if you stop there, you are going to underperform on your exams, and that's where the bulk of your grade will lie. So don't stop here. Use it as a springboard. Once you complete your Canvas homework, jump into the practice problems in the textbook. That's going to be the best way to prepare for the tests. All right. Let's talk a little bit about time requirement. All right. This class has 2 2-hour lectures, a week, and then a 3-hour lab. So there's 7 hours of class time. All right. The general rule of thumb for most college courses is 1 hour in class should equal 2 to 3 hours studying. And this is fairly accurate, especially for chemistry. Chemistry is a hard science, and they call it a hard science because it's hard for many people. So everybody takes a different amount. You're going to need to find the amount of study that you need that works for you. But a good rule of thumb, a good thing to shoot for, is for every 1 hour in class, that's 2 to 3 hours studying. This means that you should be shooting for 14 to 21 hours of study each week. If your schedule can't accommodate that amount of time, you may want to consider taking this a different semester when you have less going on. I know we all have different commitments, different, there's work, there's life. Some of us have kids. Some of us have heavy course loads, right, where we got other classes going on. If you can't devote sufficient time to preparing for this class, you won't be able to perform well. And so only you can make that call, only you know what you need, but know going into it that you should be shooting for 14 to 21 hours of study each week. That comes out to be 2 to 3 hours a day. Now, something that you should be aware of as you're trying to manage your time, because it's something that we all have precious little of, right? Oops. You want to focus your study on active learning. Active learning is better than passive learning. All right. What do I mean by active learning versus passive learning? Passive learning is what you're doing right now. You're sitting in a class, you're listening to a lecture. Active learning is problem solving. This is the skill you need to practice if you want to succeed in this class. When you think about it, when you sit down to take a test, what am I testing you on? I'm not testing you on your ability to do a lab experiment. I'm not testing you on your ability to listen to me talk. I'm testing you on your ability to solve problems, to take a set of data analyze it, solve the problem, find the answer, find the solution. All right? It's a lot like math in that way. If you are not daily solving new chemistry problems that you haven't seen, you're not preparing yourself to take the exam. That is the one thing that you're going to do on the test. So if you're not practicing doing this procedure, if you're not practicing solving new problems, you're not getting ready for the exam. And there's a deception, there's a deceptiveness to study. I find that some students, they'll come to me after taking a test and underperforming or not performing up to their desired level, and they'll say, I don't know what went wrong. I watched your lectures 3 times over, or I don't know what went wrong. I do the examples that you did in lecture over and over and over. The thing is, when you're studying, if you've already done a problem and you've got it right, doing it again will not prepare you for the test. It will not help you. Problems are only useful if they're new. So work as many problems as you can, but as many new problems as you can. Even if you took all the problems that I assigned from the back of the book and you did every single one of those 3 times through, that first time would be helpful. But the second time, if you've done every homework problem assigned, you need to find new problems. Go to the internet, Google chemistry topic, worksheet PDF. And Google will spit out more problems than you can do from universities and colleges all over the country. All right, work new problems. Don't work old problems, because the old problems won't help you. You need fresh blood every time. Okay, so you want to engage in this thing in active learning. You want to devote enough time to it. And the last thing that I'll say here is often students will tell me, like, I studied for 14 hours straight the 2 days before the exam. If you do this massive thing right before the test, this is a hard class to cram for. Some students can pull it off, but it's a hard class to cram for. You would be better, instead of spending 6 hours the day before the exam studying for the exam, take that 6 hours, break it into 1 hour chunks, and do 1 hour a day for the 6 days leading up to the exam. Far more effective for your study time and your performance than backloading it all into a massive study session 1 or 2 days before the test. So that would be my recommendation for time management. Definitely emphasize active learning. Okay, we're almost done with the syllabus here. One thing that I want to mention is FLC tutoring. Is awesome. And free. All right, the tutoring center employs students who passed this class with good grades. So hit them up. They're free. You don't have to pay for them. The college does, so you don't have to. The tutors are great. It's an excellent resource. If you need extra help outside of class, hit them up. They're awesome. I know in the previous semesters they've been online. I don't know if they're still on. I think they are, but don't quote me on that. They may not be in person yet because we're digital right now. So they may be doing a hybrid. I'm not sure exactly. But hit up FLC Tutoring. They're on the Folsom Lake College website. All right. One last thing I want to mention, then we can actually start talking about some chemistry, is in-person versus remote instruction. So this semester we're supposed to be in person, but right now we're remote. I've mentioned it before, but the plan is to be back. We're supposed to be remote for 2 weeks. And then in person for the rest. Of course, we have to point out the reason why we're remote for 2 weeks is because the Chancellor's office made an emergency declaration. Could they do it again? They totally could. They totally 100% could. Do I have any idea if they will or not? I don't. So we're all kind of in this weird limbo space together. We're going off of what they said. We're online for 2 weeks. Then we're actually meeting in the classroom at 8:15, which will be rough, but we'll get through it. They could change things. We just don't know. So all that to say is, the plans that myself and the lab instructor have made are to return, because that's what they're telling us. If they shift things, then the format of the class is also going to shift. Then we're going to have to do labs online, which will be a different thing. We're not crossing that bridge yet because we haven't been told to. But I would have to reformat, like, for example, the types of exams that I give, because if we're not meeting in person, then we're not taking written exams. They've got to be digital. So all this to say is the syllabus is tentative. It's based on the plan of being in person, but if things change, I will need to change the structure of the course, and I will explicitly let you know what those changes are, so that there's no surprises, but I'm not crossing that bridge until we get to it. So I sincerely hope with all my heart that we will be present in the same room. It's been a long time. It's been 2 years since I've been in a classroom teaching, and I hope that this is the semester of the return. But we'll have to just to wait and see. Okay, that is the end of syllabus talk, which means we can resume, or not resume. We can start talking about chemistry for the first time. Okay. So let's do that. All right, hang on 1 second. Let me pull up my notes. Okay, so we're going to dip into chapter 1 very briefly, and then we may even get to start chapter 2 today. Let's see how this goes. So welcome to Chem 305. We are here to talk about chemistry. All right, and if you were to ask, well, what is chemistry? The answer that you might get, probably the most common answer, would be the study of matter. Chemistry is the study of matter. And though that's not wrong, it's not a wrong answer. It's missing a little bit of a shade of meaning. All right. So what is the thing that chemists are known for? Right. What are we famous for? We're famous for chemical blanks, right? We're famous for chemical reactions. All right. That's chemical reactions, chemical transformations. That's changing the structure and composition of matter. That's what's involved in a reaction. All right, a chemical reaction changes the structure and composition and energetics of matter. And so, really, I favor as a definition, chemistry is more the study of change, of how matter changes, reconfigures itself, um, explodes. But that's not the only thing chemical reactions do. All right, and so that's really, even though the definition that chemistry is the study of matter is correct, I tend to agree with the introductory episode of Breaking Bad where Walter White says chemistry is the study of change. It's a good definition. Now, if we're going to learn how matter changes, we need to know what matter is, right? We need to know what matter is. Well, matter is one of the two things in the universe. I don't know if you know this, but there are two things in the universe. There's matter and there's energy. All right, matter plus energy equals the universe. All right, the whole thing. Matter is the stuff in the universe that has mass and takes up space. A crude approximation of mass is weight. So if something has weight, it has substance, and it takes up space, that's matter. All right, that's the physical stuff. And matter comes in three basic flavors. All right, matter comes in three basic flavors. There are solids, liquids, and gases. Solids, liquids, and gases. Now, there are, I'm sure, some phase aficionados in the audience who might be screaming at me right now, what about plasma? Plasma is totally a thing. We're not going to talk about it because this is an introductory chemistry course, and if you want to learn about plasma, you need to hit up physics and not the introductory stuff, like the actual physics with calculus in it. So it's beyond the scope of this course. There are three basic flavors, I said. They're not the only flavors. But we have solids, liquids, and gases. Now, one way you can categorize each phase is by looking at the shape of the phase and by looking at the volume of the phase, of a sample of some substance in that phase. So, for example, if we're looking at shape, a solid has a definite shape. It has a definite shape. If you have a solid something like this stylus, its shape isn't going to change, right? If you have a liquid, like the water in this water bottle, its shape does change. As you can see, it's got an indefinite shape. Its shape is changing as I rotate it. So we'd say that solids have a definite shape. Liquids have an indefinite shape. And gases have an indefinite shape as well. The air in this room is a gas, and it is changing shape as my solid body moves through it. It's constantly in flux. So solids have definite shape. Liquids and gases have indefinite shape. All right? But now let's talk about volume. Solids have a definite volume. All right? Gases have an indefinite volume. You can compress gases, right? Like those gas tanks that always blow up in movies. So gases have an indefinite shape. They can be compressed. They can expand. They're pressure sensitive. Liquids, though they have an indefinite I'm talking about volume. Solids have a definite volume, gases indefinite volume, compression, expansion. Liquids, though they have an indefinite shape, do have a definite volume. So even though we saw with my water bottle how it's sloshing around changing shape, the volume inside this bottle is always 24 ounces, unless I remove some. No matter what shape it has the same volume throughout. So this is one way of kind of categorizing and differentiating the different phases of matter. Solids are those substances that have a definite shape and volume. Gases are indefinite in both their shape and their volume. And then liquids have an indefinite shape, moldable, but a definite volume. There's a substance there that won't change. So that's one way of categorizing matter. Now, matter can undergo two types of changes. There are two types of changes that matter experiences. There are physical changes. Oops. And matter can undergo physical change. Matter can also undergo chemical change. All right, physical change is change that does not alter the chemical structure. All right, physical change does not alter the chemical structure. Chemical change does alter. I should add of matter. All right, so what would be an example of a physical change? Well, I actually underwent a physical change yesterday. Haircuts. I got a haircut yesterday, which would be a great example of a physical change. It's a physical change because it definitely was a change in the matter on top of my head, right? It's a different shape now than it was. But the chemical structure of my hair did not change as it was being cut, as it was being buzzed and it fell to the floor. If you were to look at the molecular structure of my hair, it's exactly the same as the molecular structure of the hair on my head. The chemical structure of the matter of my hair did not change. That makes it a physical change. So what would be an example of a chemical change? Haircuts, physical change. Setting my hair on fire. Would be a great example of a chemical change. Because let's say I burned my hair off. After I put out the flames and hopefully haven't seared my scalp too badly, is there any hair left? No, there's not. All of my hair, if I burned it all off, has been converted to carbon dioxide and water. I have altered the chemical structure of my hair. It's not hair anymore. It's different molecules. That is a chemical change. A physical change, it's hair before, it's hair after. I've just physically changed the shape of it. A chemical change, I have altered the structure of the matter itself, and now it's something different. physical change, chemical change. All right. So we can look at how matter changes, and there are those two different types of changes. We looked at one way of classifying matter is by looking at the phase the matter occupies, solid, liquid, and gas. It's not the only way we have to classify matter, however. So another classification scheme of matter is we can break it down into two basic categories. We can say that matter is, we could say that something is a pure substance. Or we could say that a particular sample of matter is a mixture. All right, so you have all matter. All matter can be broken down into pure substances and mixtures. All right, now a pure substance is one thing. Everything in the sample of matter is one thing. So, for example, an example of a pure substance would be a gold ring. Because a gold ring is a round chunk of metal where everything is just gold atoms. Just a bunch of gold atoms. A bunch of gold atoms stuck together in a clump. Everything in that piece of matter is gold atom, gold atom, gold atom, gold atom. They're all one thing. Another example of matter, a pure substance, would be water. Right? A sample of water has more than one element. Water is H2O, but it's H2Os in repeating units. It's a H2O, H2O, H2O. So water is an example of a molecule, or I should say, a molecule or a compound. So you can have a compound that's a pure substance because it's all one thing. It's all that compound. A gold ring, because it's all the same atom, is an example of an element. All right. Now, for mixtures, if we're talking about a mixture is more than one thing. So mixtures come in all varieties, because you can have a mixture of 2 things, you can have a mixture of 8 things, you can have a mixture of 35 things, and it goes on and on and on. There are 2 types of mixtures. So one example is you could have coffee, my morning coffee, which is a mixture of well, I was about to say 2 things. It's a mixture of coffee and cream. Because I just take cream in my coffee, but it's actually 3 things, right? Because it's the extract of the coffee beans, it's the water used to make coffee, and it's the cream. So 3. We could even maybe break it down even more. But coffee is a mixture, and it's not just a mixture; it's a specific type of mixture. It is called a homogeneous mixture. It's called a homogeneous mixture because it's the same throughout. If I take a sip off the top of the coffee, it'll taste the same as if I put a straw in and took a sip off the bottom of the cup. Granted, I'm not drinking French press because that would be a heterogeneous mixture, because it wouldn't be the same throughout. But I don't use a French press, so my coffee is uniform throughout. That makes it a homogeneous mixture. Um, Another type of mix, the other type of mixture would be example a soil, right? You've got dirt, you've got rocks, you've got some plant matter, maybe a pill bug crawling around in it, and it's not the same throughout. It's not evenly distributed. There's chunks where it's more rocky, or maybe there's more pill bugs or more roots. Um, so soil would be an example of a heterogeneous heterogeneous mixture. All right, and that is another classification scheme to separate and differentiate types of matter from each other. All right, the last thing that I want to touch on in chapter 1 is is uh, is a little intro to the periodic table. All right, the periodic table of elements. We're going to get a lot of use out of this thing this semester. Um, we have all the elements known to us listed out, but it contains some very specific and pertinent information that I just want to make sure we're all on the same page. Excuse me. So this may be review for some of you, but definitely not all of you. So every cell in the periodic table contains the same type of information. So if you take, for example, everyone's favorite element, silicon. All right, there are going to be a series of symbols and numbers in the cell on the periodic table. And I just want to break these down. So first, this is the elemental symbol. All right, and one thing that I want to say about the elemental symbol is you'll notice that it is a capital letter followed by a lowercase. Not every symbol has two letters. Some symbols, like oxygen, is just an O, carbon is just a C. But there are some elements like silicon that have two letters in them. The first letter is capitalized, the second one is lowercase. You need to know that you have to differentiate these two from each other. That one is capital, one is lowercase. And here's why. So, for example, iridium. You'll notice that I write iridium as IR, and you're like, well, technically, that R that you have right there is, isn't this a capital R? Yes, but you'll notice I've drawn it smaller, and that's the point. The second letter must be small. And here's why. Let's look up the element cesium. It's CS. If you don't draw that S smaller, this is carbon plus sulfur. Whereas this is cesium. and those do two different things, do mean very different things. If you do not make that second letter smaller, you will be losing points on exams and stuff. So that's just one thing I want to point out from the beginning. You don't have to technically draw this as IR. I'm fine if you write a capital letter. You just got to make sure that it's smaller, because if you draw them the same size, they mean different things and you're going to lose points. So just know that from the start. All right, so that's elemental symbol, the first thing we need to know. Up here, we have what's called the atomic number. Or I guess what will come to be known in future generations as the atomic hashtag. The atomic number is represented by the symbol capital Z. So sometimes you'll just see Z equals 14, and that means atomic number equals 14. The atomic number tells you the protons in the nucleus, down here, this is self-explanatory. This is the name. Not every periodic table includes the name underneath the elemental symbol. The one that I will provide you on the exam does. So you do not have to memorize the names of any element in this class. You don't have to memorize element names. They'll be on the periodic table that you'll have to take every exam with. And then finally, down here, you have a second number, and this is called the atomic mass. And the units for atomic mass, you'll notice no units are written, but the units are units of AMU, which stands for atomic mass unit. All right, so it's not explicitly written on the periodic table, but it's just known that all of the atomic masses are reported in AMU, in atomic mass units. Okay, so that is the quick kind of intro to the periodic table. We'll use this carrying forward, and this brings chapter 1 to a close, but we still have about 30 minutes, so we're going to dive into chapter 2. All right. Now, chemistry is a physical science, right? It is a physical science, and we are out in the world, we're in the lab, we're making observations, we're taking measurements. And we're used to thinking, growing up in the US, we're used to thinking in terms of the English system of measurements, which are feet, miles, pounds, gallons, etc. But in the scientific community, we use the metric system, sometimes called the SI system. All right, now with the metric system, that is the one that we're going to be using in this class, and so we need to spend a little bit of time getting acquainted. So the basic unit of length. In the metric system is the meter, which is abbreviated with an M. And 1 meter is 1.09 yards, for example. So it's a little bit, 1 meter is a little bit longer than 3 feet. The basic unit for mass is the gram, which is abbreviated with a lowercase g, and 454 grams is 1 pound. There we go. 1 pound. So, 454 grams is a pound. About, yeah. So, that's what it is. A gram is a much smaller unit of mass than a pound. Technically, pound is a unit of weight, and the physics aficionados in the audience will get upset with me for calling weight mass. They're different, but there's a linear correlation between the two, given that we're in a constant. Anyways, if you're a physicist and offended, I have no idea why you're in an introductory chemistry class. Let's leave it at that. So the gram is the metric unit for mass, which is roughly the same thing as weight. If we talk about units of volume, the metric unit for volume is the liter. It is abbreviated with a capital L, not a lowercase l. And 1 liter is roughly the same as 1 quart. 1 liter is 1.06 quarts. Excuse me. So these are the basic units for the metric system: meters, grams, liters. All right. Now, the reason why the scientific community relies on the metric system is because their units are very flexible. So, for example, with length in the English system, we have an inch, then we have a foot, 12 inches in a foot, and then we have a yard, 3 feet in a yard. We have a mile, which is 5,280 feet. There's no rhyme or reason to the English system. The metric system has units that scale, and they're all based on powers of 10. So it's just cleaner. And this system of in the metric system, we use prefixes to modify our units. So these units you need to memorize. I try to keep memorization in my classes to a minimum, but the metric prefixes are just something that you need to know off the top of your head. So I'm going to give if you look in your book, there's a ton of prefixes. You don't have to memorize the table in your book. You do need to know the ones that I'm going to write down now. So this is going to be, you're going to need to know these for every test you take in this class. Except for the prereq exam, because that is only algebra. But starting with exam 1. So there's the name, the prefix, and the multiplier. And we're going to use these in examples in just a moment here, but I want to get this table out. So one prefix is kilo. The prefix that's actually used is a lowercase k, and then the multiplier is 10 to the third because kilo is 1,000. So, for example, 1 kilometer is 1,000 meters. 1 kilogram is 1,000 grams, etc. Another prefix that you need to know, you need to memorize, is centi. Its prefix is a lowercase c, and its unit multiplier is 10 to the negative second power. Next comes milli. The prefix for milli is a lowercase m, and the multiplier for milli is 10 to the negative third. You also need to know micro. Now, we can't use a lowercase m because milli took the lowercase m, so we have to use mu, which is the Greek letter for m. That is micro, and it's 10 to the negative 6. Nana. Next we have nano, and this is the last one you need to know for this class. It's a lowercase n, and it's 10 to the negative 9th. All right, now, I know I mentioned this before, but you need to have these things memorized. You need to have these things memorized because you just need to know them off the top of your head. Okay. So start now, make some flashcards, get these things in there so that you're just breathing them by the time you take exam 1. Now we will practice using these unit conversions in a minute, but before we do, we need to talk about significant figures. If you have any previous exposure to chemistry or physics, you have heard these two words put together before, and judging by the experiences most people have, it's probably a negative experience with significant figures. Something that I want to tell you up front in this class. So I am going to issue a caveat emptor. Which is Latin for buyers beware. All right? Buyers beware. In this class, on exams, the correct answer on any test to any problem must have correct significant figures. All right, it must have a correct significant figures. In this class, there are 3 things that make an answer right. So correct answers have here, actually, let me chop this off, give myself a little more room. So correct answers will have, first, the correct value. This is the number that you calculated. Second, a correct answer must have correct units. If you did a calculation and the answer for it was 454 grams, but you write 454, that's a wrong answer. The unit is just as important as the actual number you're calculating. And then finally, the correct answer will have the correct number of significant figures. I realize I haven't gotten into what significant figures are. I'm about to in just a second here. But you need to know from the outset that on the exam, there are points for the value, the units, and the sig figs. And if you miss any one of these, you're losing points. The only way to get all points is to have the correct value, units, and sig figs. And I just want to be upfront about that from the outset of class. There was a semester in the before 4 times when we used to meet in person, where I heard a student kind of the day I passed back an exam. You know, it's a good day for some and not a good day for others. And there was a disgruntled student who was really salty about their test. And during the lab period, it was this class I was teaching lecture and then lab after it. And during the lab period, I heard the disgruntled student mumbling to their lab partner, and they called me a sig fig Nazi, which is ironic because I'm Jewish. The reason why I bring it up is I want you to know from the beginning that this is something I emphasize in the class. And so if you are going to do well in this class, you have to master this thing that I'm about to dig into. It's going to seem weird. Most of you are not going to like it. I'm not asking you to like it. I am asking you to learn it. And if you don't, you're going to hemorrhage points. So let's just tackle this. Let's master it from the beginning, and you won't be mad at me come exam time because you'll have earned these points, and everything will be great. All right. So, what are significant digits or significant figures? So, something I'll let you know from the beginning is significant figures, significant digits. They mean the same thing. You'll hear me call them both. It's because they're interchangeable. So, question. What digits are significant? All right. And there are three parameters that qualify a digit within a number for being significant, for significance. The first is all non-zeros are significant. So if a number is not zero, it's a significant digit. 2, a zero or a zero between significant figures is significant. So if a zero is in between significant digits, it is significant. So for example, in the number 101, we have two significant digits. We've got two non-zeros. One is significant, one is significant. But then this zero is in between significant digits, so there are 3 significant figures in this number. If you look at another example, 12.006, you'll notice that we have 3 non-zeros, so all of those are significant. But then these zeros lie in between the 2, which is significant, and the 6, which is significant, which makes them significant. So 12.006 has 5 significant figures. All right, so that's one way a zero can be significant, is if it's in between significant figures. And then the third and final way, that is I guess it's the second way, but it's the third criteria. The second way a zero can be significant is a zero that is to the right of the decimal and at the end of the number. Is significant. All right, a zero that is both to the right of the number and right of the decimal and at the end of the number. This and is super important. All right? This and is super important. You have to be both to the right of the decimal and at the end of the number to be significant. So, for example, if we were asked to determine the number of significant digits in 10.00, all non-zeros are significant, which means that number 1 is significant. Our third rule, a zero that is to the right of the decimal and at the end of the number. There's only one of those. This 0 is to the right of the decimal and at the end of the number. That's significant. Now, these 2 zeros are in between 2 significant digits, which also makes them significant. So this number has 4 sig figs. Let's look at another example. 0.00360. Which digits are significant? Our 3 and our 6 are significant. Now, do we have a 0 that's to the right of the decimal and at the end of the number? Yes, but only one of them. This 0 is to the right of the decimal and at the end of the number. What about our remaining zeros? Well, they're not to the right of the decimal and at the end of the number. Also, these 3 zeros are not between significant figures. So these 3 zeros, are not significant, which means that this number has 3 significant figures. All right. So that is how you apply the rules for sig figs, how you can look at a number and determine the number of significant digits within that number. All right, let's see. How are we doing on time? Okay, I'm looking at what comes next, and we're about to dive into a lengthy discussion, and I don't believe we can finish it in 10 minutes. So I'm going to go ahead and call lecture there. Thank you, everybody, for showing up. We'll be back here. I'll be back here same time on Monday, 8:15 to 10:20. Again, the little live stream thing will pop up on YouTube. You know where to find me. So have a great weekend. We'll continue our discussion of where significant figures come from and how to use them in mathematical calculations next week. But again, I don't want to dive into this because we have 9 minutes left, and the discussion is going to take longer than 9 minutes. So we're going to save it all for Monday. So get out there, take that syllabus quiz, lab on Friday. Your lab instructor will be going over some algebra review, hopefully, and give you more information about the lab course. So check your lab canvas for that business. And I'll catch you all on Monday. Have a good weekend.